hands up. That's a polygon. So you know the shapes. Okay? No, it's not a shape. What's a polynomial? Yes, 10 meet.
It's like the number of 10.
Okay, so it's an expression. I'm hearing you talk about multiple terms. It's an expression with multiple terms. What's a term? So these are, with the numbers and the variables, what's the number out in front of a variable? So it's going to be a good coefficient. So it's a coefficient. Yeah, because we did it right at the beginning of the last chapter too. So I'm reviewing definitions for you.
This test is literally, is it everything that we've done?
No, just chapter 3 and 4.
Just chapter 3.
Yeah. So it's coefficient and variable. Or, if there's no variable, what do we call it? Constant term, or a constant. Or a constant. And then Nika, you define something here. Separated by addition and subtraction. Cool, love it. So we had terms. So polynomial is an expression with multiple terms, and a term was a coefficient and variable, or just a constant, separated by addition and subtraction. That's cool. Multiple means more than one. Technically speaking, you can have a single-termed polynomial. Here, let's just tweak this then with an expression with one or multiple terms. There we go. Now we're changing things here. Multiple terms, separated by addition and subtraction. There's some more language here that restricts what kinds of things can show up in a polynomials. So a polynomial must have, I'll say it this way, non-negative integer exponents. Okay, so what does it mean for things to be non-negative integer exponents? What kinds of things are we restricting, Rebecca?
No negative.
Okay, so no negative exponents. But no negative exponents also implies something else. You can have integers means no fractional exponents. Leaves the space there. Each one of those has an implication. If I'm not allowed to have negative exponents, what am I not allowed to do in a polynomial? Divide by what? No. The negative exponent probably is going to show up on, sorry, I say it this way. Must have non-negative integer exponents on variables. Which means if I'm not allowed to have negative exponents on variables, the implication here is then that I'm not allowed to divide by a variable, because a negative integer is going to put it into the denominator. So it's no dividing by variables. And no fractional exponents means no what? Should do this since it's easier to see. What does the world of fractional exponents open up for us? Radicals. Yes. Yes, roots. No roots on variables. Okay? So to come up with polynomial, there are restrictions now to what we consider a polynomial to be. So based on these restrictions, which of my expressions here are polynomials? Or even easier, which ones are not polynomials of these 9? The first one is not? Okay, let's just do this. Is this one a polynomial, yes or no?
Yes.
Why yes? Because all my exponents on the variables are positive, and I'm not dividing by any variables. Cool. So this one's good. When you said third one, were you going left and right or up and down? Okay, you know what? Let's go down. How about this one? Is this a polynomial? How about this one? Why not? Okay, so that's the problem right there. So no. How about this guy here? Okay, so we're good. He's good. How about this guy?
No.
Dividing by a variable, not allowed to do that. Bam, not a polynomial. How about this guy? What's the problem? The root's the problem. Good. How about this guy? Yeah, there's no restrictions on your coefficients. Your coefficients can do whatever you want. But there's restrictions on the variables. Here, there's nothing going on with the variables that is bad. So we're good here. This one's a good one. How about this guy here? What's the problem? The negative exponent on that b. Cool. And then the last one here. The rooting is only on the coefficient, so this one is still good. Okay. Okay, so welcome to the wild and wacky world of polynomials. You don't like it. Okay, well, too bad. So, monomial. Does anyone remember what a monomial is? Carolyn. What, sorry? A one term. So what's an example of a monomial? Sorry? 6a. Sure. What's a binomial? A two-termed polynomial. Someone give me an example. 5a plus 2y. Cool. What do you mean? Yeah? Yeah, there's still two terms there. Trinomial, does anyone remember? Three-termed trinomial or polynomial. Someone give me an example. 5a plus 2y plus 8, sure. In general, so we have specific language here for a one-term polynomial, a two-term polynomial, a three-term polynomial. Past these three, we call, I shouldn't say past, this should be just past with a T. Past these, like beyond the monomial, binomial, trinomial expression, so past these, we call anything bigger a blank termed polynomial. So like we don't have an expression for a four-term polynomial. We would just say that this is a four-term polynomial. The first three have special names. Everything else we don't. Coefficients. We remember what a coefficient is? A number multiplied by a variable. You can also have a divided one, but if it was a polynomial, if I had 5x here, what's the coefficient? It's 5. If I had x over 5, what would be my coefficient? Sorry? It would be 1 over 5. Which we definitely did at the beginning of the first chapter, or the last chapter. Okay, so it's this section here in green that is useful for you to remember for tomorrow, for reasons. Tomorrow's on the test. Because if you remember at the beginning of chapter 3, we defined some expressions using one term, two term, three term. Now, the thing we haven't talked about yet, this is all going to be new here, this next section here, is the degree of a term. So everything we did in the previous chapter, all of those expressions, almost all of those expressions, were what we call linear. I introduced a couple at the end that started to have exponents on variables, but for the vast majority of what we did, there were no exponents on the variables in the last chapter. Now, when we start adding exponents to things, it starts to change what we call the degree. And the degree of a term is, we define it to be the sum of the exponents on all variables. Okay? So the degree of a term is the sum of the exponents on all variables in that term. This is just a way we describe terms now, is by talking about their degree. So, if my term is 3a, let's talk about my coefficient. Let's get the coefficient out of the way. Coefficient's 3. Now let's talk about degree. I defined the degree to be the sum of all of the exponents on all of the variables. My variable here is a, and my exponent on the variable is 1. So this term has a degree of 1. This next guy here, 8x to the 7, the coefficient is 8 and the degree is going to be? Cool, nice and easy. But what happens now when I start to bring in multiple variables with different exponents? Here I've got negative 4x squared y cubed. So what's my coefficient on this thing? It's negative 4, good. Now what's the degree on that thing going to be? It's going to be 5. Because I'm summing up all of the exponents on all of the variables. Next guy, 5xyz. 5 is the coefficient, 3 is the degree. Because my exponents on the x, y, and z are each what? Each a 1. Cool? Okay. P over 5, the coefficient is? Oh, look at that. It's the same one we just did. And the degree is? Cool. Next one. Negative 3 over 7 is the coefficient, and the degree is? 1 again. Cool. The next one. There is no coefficient because there is no variable. Cool. So if there is no variable, what's the degree? It is 0. And then this last one, coefficient's going to be? if there is no variable, there is no coefficient, because the coefficient is defined to be the number multiplied by the variable. So there is no coefficient. And because there is no variable, there is also no degree. Degree is 0. And then the last one here, the degree is 9. Good. Do not forget to add. So we've got the c has an exponent of 1 plus 6 plus 2. Love it. Nice and easy. So this is the concept of degree. Now if you flip the page, so that was the degree of a term. Now let's talk about the degree of a polynomial. The degree of an entire polynomial now is going to be the greatest degree of a term in the polynomial. Okay, that's how we define the degree of a polynomial. It's you look at every individual term and then you pick the biggest one. So, this guy here, what's the degree going to be? It's going to be 1. Because the degree of this term is 1, the degree of this term is 1, and the degree of this term is 0. So the biggest term is 1. So that's the degree of the entire polynomial. How many terms does that thing have? It has 3 terms. 1, 2, 3. And it has a constant of? What are my coefficients, just for fun? Yeah, we're going to add a column here at the end. Let's add the coefficients in here. The coefficients are what? Almost. 4 and negative 3. Remember, we need to bring out the sign in front of the coefficient. Cool. Next one. What's the degree on that thing? It is 3. Good. You don't add degrees on term to term. You just add them up on a single variable or all the variables in a single term. So the number of terms here is going to be 3. So what kind of polynomial is this one? It's a trinomial. Okay, cool. The constant is, and my coefficients are negative 4 and 2. Love it. Also going to be useful for you tomorrow. The degree on the next one, what is it? It is 4. The number of terms are, so what kind of polynomial is it? It's a binomial. Cool. Constant is? It is negative 81, and my coefficient is 9. Love it. It's coming them back. Next one. What's the degree? Is it 7 or 8? Is 8 bigger than 7? It's 8. Okay. Remember, the degree of a term is the sum of the exponents on all the variables in that term. So what's the degree of this term here? This degree is, this degree is, and this degree is. So the largest degree for the polynomial is 8. How many terms are there? Constant is? There is no constant. Cool. And the coefficients are? 1, negative 1, 3, and negative 3. Good. If there is no coefficient listed, then what is the number that we assume is multiplying out front? It's 1. Good. And the last guy here, the degree on that thing is? Number of terms. Constants. Coefficients. There aren't any. Cool. So, Now that we've talked about degree and we've got a kind of working understanding of this thing, typically in a polynomial, so this is going to be typically here. Typically, in a polynomial, we order the terms a particular way. The terms get ordered, usually, from largest degree to smallest. Usually. There is a, I'll put a little star down here. There will be exceptions to this. And the easiest way to deal with the exceptions is instead of me telling you all of the exceptions, you'll see them as they show up and you'll be like, oh, okay, fine, I can do that. It's not, ordering these things really isn't a big deal because we can add, subtract in any order we want. So it doesn't really matter, but there's conventions to teach you guys here. So, for example, if I have these four polynomials here, if we're going to order them from largest degree to smallest degree, what would I do with number 1? Does anything have to happen with number 1? No. Nothing has to happen because the degree on every term is 1. Now, the one exception is sometimes you get neurotic mathematicians who like to keep things in some sort of order. So how many of you are a little bit bothered by what's here? Often the variables are the thing that take charge. So sometimes we would order this in alphabetical order on the variables. But if we care about the degree, then there's nothing we can do, nothing we have to do. But sometimes you get people who are like, you know what, I would rather have it in order of alphabetical variables. That's totally normal. Don't have to, though. Number 2, what would we do with number 2? Danny. Which would be what? What's 7x squared minus 2x squared? You're putting these together. So that's just going to be 5x squared, and that's the thing that's going to come out front. The next thing's going to be minus 3x plus 10. So you want to be able to group them and then put them in the right order. Number 3. What's number 3 going to look like? Sorry? Careful, we want to keep them in order of degree from greatest to smallest. So it's probably going to start with a squared, yeah? Good, plus 2b squared. Minus 7a minus c. Cool. Questions about anything that happened there? It's -2 and -5. So no. That was Acom, right? Acom was correct. And then number 4. 4 is a fun one. Takes you back to grouping terms back before. What would we do? Okay, so it doesn't really matter which order. So this is another one where there's a particular convention here. what we would do, well, there's three that are all the same degree. The x squareds, the y squareds, and the xy's. Those are all the same degrees. And then you got the constant term. So this thing's going to end with plus 2. This is where that alphabetizing things kind of comes in. So the first, if we're going to add the alphabetization in there, what's the first term going to be? Negative 3x squared. That's that guy. What's going to come next? What would make sense to come next, do you think? Yes, because the that is correct. I know it's a little weird, but the xy terms are going to come next because xy is like between x and y. So what's that term going to be? Plus 6xy. Good. Remember, the xy here and the yx here, just because the variables aren't in the same order, doesn't mean they're not like terms, because the exponents are the same on both and the variables are all the same there. So we're good there. Plus 7y squared, and then you have that plus 2 at the end. So that is typically, so you see now there's some examples here where we don't have to write in alphabetical order, but convention would encourage us to. Sorry? It's only been 5 minutes since what? Since you looked at the clock last? Don't you hate it when class drags to a halt? Okay, this is the last thing we're going to look at here. Identifying equivalent polynomials. This is easy. You can do this. I believe in you. Order of terms in a polynomial matters in regards to proper mathematical form. So what I mean by this is everywhere where I've said convention, convention it's just the way we do it. But it doesn't actually change the value of the expression. So two polynomials with the same terms, regardless of order, are going to be equal to each other. So something like this, 8x cubed plus 3x squared minus 5x plus 10, is going to be the same as 10 plus 3x squared minus 5x plus 8x cubed. Even though the terms are in a different order, we're allowed to add or subtract in whatever order we want, right? Like 2 plus 3 plus 4 is the same as 3 plus 2 plus 4. Both of them are 9. So even though this is how we would write it, we wouldn't typically write it like this. That doesn't mean that these two expressions aren't the same. Even though we would not write this expression like this. Just because the order is different doesn't mean they're not the same. Okay? And we can prove that by putting a value in for our variable and solving for it, which you're going to have to do on the quiz tomorrow or test tomorrow, so we may as well do it now. I've given you a value, x equals 2. If I plug 2 into this, what do I do? It's going to be 8 times 2 in a bracket cubed, plus 3, replace the x with a bracket, put my 2 in there, close it, squared, minus 5, bracket 2, plus 10. We remember this, yes? Kind of, sort of. So then, what's it going to be? 8 times 8, which is 64, plus 3 times 4 is 12, minus 10 plus 10. So 64 plus 12 is going to be 76, and then I'm subtracting and adding 10, so nothing happens there. So that's just going to be 76. And if I look over here, it's going to give me the exact same thing. It's going to be 10 plus 3 bracket 2 squared minus 5 bracket 2 plus 8 bracket 2 bracket 3. So then this one's going to become 10 plus 12 minus 10 plus 64. Again, it doesn't matter which order I do the addition and subtraction. 10 plus 12 is 22, minus 10 is 12 again, plus 64 is 76. Was that just a little too? We follow, kind of, sorta. Yeah, I went in order from left to right. Okay. So then, the last thing I'm going to ask you guys is this. There's 4 polynomials there. Which ones are equal? Or equivalent, sorry. Just by looking at them, tell me which ones are equivalent. And then I'm done. You can use the last 25 minutes to do whatever you want. These two? Because there's not a -5. So these two aren't the same. 10 meet, you have an idea? The first one and the first one and the third one. And those are the only ones. Even though the variables are different, doesn't change the fact that these are equivalent polynomials. That's it. I have some practice for you, but you don't have, this will be due Thursday. Okay, so you can either, if you're done the review, feel free to start working on this now. This is going to be homework due Thursday. There you go. On your mark, get set, giver. And you can go back to the review. Work on whatever you want for the last 25 minutes.